Okay, so the upper range was by adding the mean and the standard deviation from that mean, which is 1.7, and then the lower range is subtracting from it and the offset 1.2. Yes, positive. Oh, wait. Okay, so we have to take these numbers. It's not just doing a bunch of calculations and just going on about our day. We have to bring it together and write a summary for company B now. So the average delivery for company B, so this is the words part. Average delivery. And again, I modeled this for you for company A, so you should already have this done. The average delivery is made sometime between okay. And then before we write the rest of the sentence, let's look at our actual wait time. Are both of these actually you waiting? Yes. On company A, we had one that was negative, right? So that one wasn't late. That one was what? Early. So for this one, they're both going to be late, both parts. So the average delivery is made sometime between 1 minute, what? Late, not early. If you put early, take that off, okay? 1 minute late and 5 minutes. Okay? And that should be our report for company B. Okay? After you did all the background calculations. Alright? Okay, so this is on the golden sheet. On the right side of your golden sheet, somewhere inside you should have space so that we can write the definition of standard deviation. So let's wrap it all up. That's what we're doing next. Okay? Can I move forward from this? Yeah. Okay. Alright, so let's write the definition, write the word standard deviation. Okay. Previously in this class, we wrote down just the definition for regular deviation. Can someone tell me what that was? On page 13. What was just regular deviation calculation? We did that when we did the pennies. What was that definition? Good. Good. So that's when you do the data value minus the mean, right? That's the deviation. So what is standard deviation then? Standard deviation is when we take all those deviations, we square them, and we find that average of the deviation. Okay. So it's the measure. Write this down. The measure. You're writing this inside the golden sheet. Okay. The typical average okay, so deviations is you doing the difference. Standard deviation is you doing the average of those deviations, okay? Which is the distance from the mean of, I just marked it after. Was the line long or what?
Yeah, it was about two
Oh, you have to go to the average distance from the mean of data value. Okay. And then today I'm going to introduce to you the notation for standard deviation. So we use this notation in mathematics, and you'll see it tomorrow. And it's actually a word that was popular probably like last year. Does anyone know what it is? It's this Greek symbol. It's like a popular word that we're using a lot. It's a Greek symbol. Nobody knows it? It's pretty. All my other classes knew it. Nobody here knows it? It's a Greek symbol, and it's a word they all used to use a lot, like in social media. Yes. It is actually the real sigma, the actual sigma for math. That's a Greek symbol. So in mathematics, we use the sigma Greek symbol to represent what? The standard deviation. So on yours, what were your standard deviations for company A? What was it? Back? What was the standard deviation? For company A, what was it? What was it? Look back. 3.07, right? And then our standard deviation for company B was 1.2? No. 1.75. Okay, so just know that this is the symbol they use to give that standard deviation. Okay. All right. Okay, this is gonna be glued finally on page 17. So this part, yeah. Page 17. I'm gonna show you the table of contents. The title for this one is the delivery problem. Okay, don't forget that on Canvas, you just have to click this image. If you're ever behind, click this table of contents and it pops up the one I have as we're going through each. Okay? Alright, while you're gluing, I'm bringing around the assignment for today. The one you just finished was the delivery problem. This is the Netflix problem. Okay, so first you want to write down at the top, this is due on Wednesday. So everything's always due 2 days after I give it to you. So today's Monday, right on there, due Wednesday. Okay? Alright, now the front part is the part that's called the Netflix problem. It's pretty self-explanatory. Just go through, read the question, and answer what they're asking. Okay? But turn to the back, because on the back there's a section where I want to write a few quick notes for the paper. Alright, first thing I want to emphasize is what is range? How do you calculate range? Max minus min, good. Okay. I had some confusion in my other classes with this. What do y'all think students confuse range with a lot? Or you might? Average, yes. Oh, did I not put? Oh, I put you. Sorry. Yeah, people usually confuse range with average. So don't forget, range means max minus min. Okay. All right. Next thing is the definition for standard deviation. We just wrote it, but just so you know, that's the average. So average. Average distance from what? From the mean. Good. Okay. That's standard deviation, SD. Okay. Alright, so if you see that those words together, average distance from the mean, that's the standard deviation. That's the calculation that we just did for DAV. Alright, then the next part, I want you to see it visually. What does a low average distance from the mean look like on a data set? Whether it's a dot plot or a histogram. What does a low standard deviation look like? So that means the distance is what? From the mean. If it's low, what does that mean? This is from the mean. If it's low, what does that mean? Your data is what? Close. Thank you. Close. They're close together. You have to know that about your data and how it looks and what it means, okay? So just draw a sketch of like a dot plot where there's data that's very close together. There's not much far apart. Okay, you might have one off to the side, but most of it is close together. That is what a low standard deviation looks like, okay? And in our company A and B, who had a low standard deviation? Whose was lower? We just finished it on the gold paper. Whose was lower? B, yeah. Okay. All right, so then now what does a high standard deviation look like on your data? If I have a high distance from my mean, what does the data look like? Separated, yes, thank you. So that means you have a lot of data maybe on the left and then more on the right, way far away from each other. Maybe a few here, but not that many, okay? So it's very far away, very far from the mean, okay? That's a high standard deviation, okay? All right, then the last thing I want to talk about is outliers. What is an outlier in statistics? Outliers? I mean, when you hear that word, you already it gives it away, right? It's like extreme value. So let's say our wait time was, between 1 to 10 minutes, right? Or like early, 2 minutes early or something like that. That's if you had a wait time of like 500 minutes. That's way extreme. You basically came you were way late. You showed up after late, okay? That's an outlier. So what an outlier does is either lower your minimum or make the maximum larger because it's so far away, right? It can also increase or decrease your range. Increase or decrease your range. Because that value is so far away, of course that's going to change the range, right? Because your range is max and minimum. So it's going to be pretty different, okay? And then it can increase or decrease your standard deviation, okay? Because standard deviation is a calculation of how far away you are from the mean. So if you have an outlier that's way off, that's going to change the standard deviation. Okay? All right. If you could go back to the front when you're done writing for the first part. This part, the reason I'm giving you class time and it's not like all homework is because you want to try to at least get to number 6 by the end of class because y'all see number 3 where it says compare your list with another group of students. Obviously you can't do that if you're at home. So that's the goal, is to at least get to number 6 down, which is interpreting the data. So this problem is talking about how many hours you watch Netflix, right? And so as you read each question, numbers 1 through 3 are only like exploring values. But once you get to number 4, what does it say there?
Value.
The actual set of values. So once you get to number 4 and on, you're not going to use your numbers. You're going to use the actual numbers. Okay? That's something that throughout the day students are going to see from that. So once you get to number 4, you're using the actual data set. And since it's only 6 numbers, This whole paper, your work needs to be shown on here. Okay? You're not going to use Excel for 6 little numbers that are less than 10. Okay? So, again, all your work needs to be on this paper for the Netflix problem. Now, can you use Desmos if you need to for the squared part? Yes, that's fine. But, again, you should know what is 3 times 3. You don't need Desmos for that. Okay? Or Excel. You know how to subtract, add, divide, and square numbers. Okay? Any questions? Okay, try to get to try to get to number 6 as much as possible, and then the back is a different problem. Okay. All right.